Okay, so this last example comes from page 258. It's example 25, and this one is a far more interesting problem because what they've given us is not the original function, but actually the derivative of the original function. Okay, so let's take a look at the example and see what they're asking us to do. So from the graph given, which is f prime, indicate the x-coordinates of any points where the original function has a turning point and determine the nature of these points. Okay, so remember that we're looking at the derivative function right now. And I know that maximums and minimums, or turning points, happen anytime that my derivative is equal to 0. So just kind of note to self that a max-min occurs when f prime of x is equal to 0. So let's take a look at our graph and see where those things happen. The first 0 that I see is here. The next one is here, here, and here. So notice that I'm not getting confused about 0 slopes right now. I'm not identifying these max and mins of the derivative function. No. I'm looking at zeros of the derivative function because those are maximums of the original or minimums of the original. Okay, so now that we've kind of identified these points, let's actually see what the values are, like if it's a maximum or if it's a minimum. So take a look here. This tells me that f prime is less than 0, it's negative, and so that means that my slopes are negative. So for the original function, the slopes are negative. But up here, f prime itself is positive, and that tells me that the slope of the original function there is going to be positive. So do you see, if I were to start drawing my sine chart for f prime, this 0 right here corresponds with a negative to positive slope. So the derivative was negative, and then it switched to being positive. So negative to positive. This has to be a minimum for the original graph. All right, how about our next 0? The next 0 is about here, and it starts from being positive. So the derivatives are positive up here. That means it goes from being positive to negative down here. This is where f prime is negative. So that means the slopes are negative. They look like that. Okay, so that has to be a maximum point. Our next 0 kind of happens here. And again, it switches from negative to positives. And my sign chart's not quite long enough, so I'll extend this. And my last 0, it switches from positive to negative again. Okay, so if I wanted to start labeling these points, the turning points, if they're maxes or mins, then I would label this one a minimum because it goes from negative slope to positive slope. This one goes from positive to negative, so this would be a max. Positive, negative, and then negative, positive, so negative to positive. This is a min. Last one is positive to negative, and so this guy is a max. Okay, and again, remember this is your derivative function. So the derivatives are negative, and then the derivatives are positive, or the slopes are negative, and then the slopes are positive. And so that's why I'm getting these shapes. Okay, next question. Determine intervals where the original function is increasing and where the original function is decreasing. So anytime the original function is increasing, that means the slopes are positive. So let's take a look at where that's happening. When are the slopes positive? Well, friends, it's really any time, and I'm going to actually switch colors here. It's any time that the slope themselves are positive. So up here and here. So those are two intervals where the slopes are positive, and so we are increasing. So I'd say kind of from this interval, this guy is increasing. And then here again, this interval is increasing. And now where is the function decreasing? Well, decreasing means that the slopes are negative. So that happens down here. So any of this stuff from out here, I'll put an arrow at the end maybe. This is decreasing slope. And then here again, the derivatives are negative. So this would be an interval where the function is decreasing as well. Oh, and then the last one being this one. So these are negative slopes off forever there. So this is where it's decreasing as well. All right. Where is the original function concave up? And where is it concave down? So this one's a much trickier question. And let's think about it really quickly. So derivative or concavity comes from my second derivative function. So let's think about the second derivative function. Second derivatives are slopes of f prime. So I'm going to begin by looking at where f prime has zero slope, because remember, those are technically inflection points. And then I know that if the slopes up to that inflection point are positive, that means it's concave up. The original function is concave up. So everything from here over is going to be concave up. So if I wanted to start making a sign chart for my second derivatives, here's how that might look. I'll place the zeros here. There's a zero here, right? That zero slope. And then a zero slope there. The slopes along this side, derivative of this function, the slopes are positive. And that means concave up for the original function. Here to here, the slopes are negative. So that means concave down. And then they go positive, concave up. And finally, negative slopes are concave down. Sketch a possible graph of f using all this information now. Okay, so this is going to be a pretty intense task, and I'll try and create some space for myself. All right, so take a look at this. I know that at -1, at this value, -1, I have a minimum. So at -1, I've got some kind of minimum going on there. All right, I also know that at 0, there must be a maximum going on. So at 0, there must be a maximum somewhere. Okay. Next one over, somewhere between 1 and 2, so somewhere kind of in between there, I have a minimum again. So somewhere between 1 and 2, I sort of hit a minimum value, something like that. And then finally, at 2, I reach a maximum. So at the number 2, I hit this maximum point here. So something maybe, I don't know, like that. All right, so there's the beginnings of shapes going on. Now let's kind of confirm that all this is working with my inflection points idea. So the inflection points, oh, check it out, are kind of right in between my minimum and my maximum. That actually makes really good logical sense to me, because I know that for a minimum to maximum, there has to be some little switch in the middle, which is the inflection point. It also makes sense that I have concave up for a minimum and concave down for a maximum. So somewhere between 0 and -1, somewhere right in between there is where I get my inflection point. So I might place my inflection point about there. All right, let's find our next inflection point. It's between, I believe that inflection point is at the value x equals 1. So at x equals 1, I might have some inflection point right about there. My final inflection point is between 1 and 2, so somewhere in between there, I get my next inflection point. And now we can just start connecting all these and making the graph. Remember that the inflection points go from concave up, so give me really nice concave up shape there, and then switches to concave down. So really nice concave down shape right there. And then it switches to up again. So nice up, and then down. And that would be a possible graph for your original f of x function based on all that stuff you just learned from the derivative and the second derivative functions.